Good afternoon, everyone. My name is Owolabi Adeniro, and I will be taking the live coding session for the DevOps intern of the winter cohort of 2022. So I welcome you all to today's live session, and I hope you guys have been having fun with your materials. So to go properly into today's coding session will be very light and very easy. It's just like a basic introduction to something that you deal more on in future lessons. So this stage is basically to introduce you to DevOps, what DevOps is in general, how it is being used in the industry. And today I'll be talking on a particular tool that is very, very integral to DevOps, a tool that is one of the most widely used tools in DevOps. And there's no way you can completely perform a DevOps implementation without having to use the tool in one way or the other. So to get into it proper, I'll begin to share my screen, and for better latency, I'll just stop my video because video and sharing of screen might not work perfectly together in tandem. So I will start sharing my screen now. Okay, the first thing I'm going to share is my Docker page. Let me share this. So I hope you can see my screen perfectly. So this screen on display is called sorry for that. It's called Docker Desktop. So the tool I'm going to be introducing today is called Docker. Docker is a tool that is basically used for containerization. Yes, containerization of apps and containerization of files. So what we mean by containerization, just think of it as having a bottle, and you want to keep you want to store some set of things inside that bottle. If not a bottle, you can say a bag, but basically bottle, a container basically, and you keep a set of files, or you keep a set of things inside that bottle to preserve its state. So once you put those things you want to put inside the bottle, once you put them into the bottle and you cover the lid of the bottle, you have done what? You have containerized the bottle. So unless there is a process that does what, that opens the lid of the bottle and puts something else inside, everything that was there at the beginning of the bottle will be the same thing that will be there at the ending of the bottle, if you try to get what I'm saying. So Docker is a way for you to like bundle files, you bundle apps together so that you preserve the state. You want a desired state for those files. You want them to be in a desired state. You want them to be in a specific way. So you don't want there to be a change, or you don't want to give up an opportunity for a way for those files to change. So one of the standard ways to do that is to use Docker. You use Docker to containerize. So you bundle everything into a container. And when you bundle everything into a container, you can now begin to share that container with different people. You can take the container from one system, put it in another system, or you can take the container, place it on the web. But the main idea behind it is that the container remains the same. So when the container remains the same, the files and the way you have structured everything inside the container will continue to be the same. There will be no change in that container. So that's what Docker does. So this is Docker Desktop. It's a tool that makes the creation of Dockers easy. So today I'll just be like showing us what a container is. You get how to spin up a container, things that one can perform with a container. Basically, there's a stage, I think that should be stage C, that deals more on this. But Docker is a very, very, very important tool in DevOps, CI/CD, anything that has to do with DevOps deployment. Docker is very important, so it cannot be overemphasized on, and there are multiple ways that one could utilize Docker for his or her own use case. So Docker Desktop is a desktop that makes working with containers, that gives you a GUI platform. a graphic user interface platform for working with Docker, because mostly we work with the command line tool. The command line tool is called Docker. So when you install the Docker desktop, you automatically install the command line tool. So you can decide to use the command line tool or to use the GUI tool, which is the Docker desktop. So we basically use the command line tool most of the time because it is easier and faster, and most of the things you want to complete examples are done using the Docker desktop, the GUI tool. So on my own Docker desktop, these are just my images, but I just want to remove these images here because I built the images when I was practicing for this stage. Okay, that's the first one, and the other one should be about 2 hours ago exactly. So I'm going to remove this also so you can see it's being built from the origin. So those are the 2 images that I don't need exactly. Every other image are images that I'm using for other projects. So this is Docker Desktop. This is a place that would list all of the images that you have, and this is a place that showcases your container when it has started. So you can see now that we have no container running. Try running a container, blah, blah, blah. This is just like Docker's sample for starting up a container, but I won't be going into that. So I'm going to change what I'm sharing now. I will change it to my Visual Studio Code exactly. So now I'm sharing my Visual Studio Code page. So basically, to spin up a Docker container, I said it is like you working with putting in a set of files. You're like bundling in a set of files together to preserve their state. So we basically use mostly when you want to deploy web apps, or when you are trying to deploy apps, we basically use container to deploy it. Why? Because it makes you able to monitor changes easily, because you can version it just like the way you have versions of apps, version 1, version 2. You can version containers. You can have logs for containers. There are basically many tools that makes you use containers. But one of the reasons, say for example, now in the process of trying to upload your app to the cloud provider, for example. So if you are using a method that maybe you upload your files to a storage space on the cloud, let's say in the event of a connection error, you won't be able to correctly identify that, okay, this is the file that has not been sent. This was the file that was being sent while the connection error happened. There are numerous ways that files that you're uploading to those kind of platforms that you're going to be using for production. There are numerous ways that those files could become corrupt. Corrupt in the sense that let's say they did not copy finish, or most of the raw details that need to be there were not embedded. There are numerous ways for that to happen. So Docker is a way for you to make sure that something like that does not happen, because you are copying everything together as a single container, let's just abstract it as a single thing, a single file now. So if your Docker uploads successfully, then everything has uploaded successfully. If your Docker does not upload successfully, sorry for that, your files have not uploaded successfully, you just start again. So it's a way for you to basically ensure that you are not doing anything that is going to get spoiled halfway, and you have much more control over, and you'll be able to spot errors easily. So the basic way to spin up a Docker container is to use a Docker image. So you use a Docker image to spin up a Docker container. So the Docker image is actually what contains all of your files that you now bring live into a container. It's just like a picture, an image normally. So a picture is a big box that contains numerous pixels. You get? So every gray box, there are if people that what a picture is on a low level part of a picture is that it is made up of different pixels. Each box of pixels, there are boxes that define pixels. So it's when those pixels come together that all of them now make a picture. So when you transfer a picture from one device to another device, you have transferred a whole set of pictures together, a whole set of pixels together, sorry, basically. So that's something that a Docker image is. So a Docker image is what contains all of the files and everything that you want to be in the container. So you bundle everything as a Docker image first, and then you spin up a container based on that Docker image. So I'll be spinning up two containers today. I've worked on them previously. Another reason why I have to have worked on them previously is because if I don't do that, I might spend a lot of time here because of what you might want to download and stuff. So it takes like some, depending on the kind of image you're trying to spin up, you can try to do something that is very large, and it might take 30-45 minutes to spin up just one. And we don't have that time here. I don't want us to even use more than 30 minutes for today's live coding session. So I had done that previously, but it's basically the same thing. So instead of the download to start from the beginning now, the download would to use cached files. Cached files in the sense that when you are working with Docker and stuff like this, when you perform an operation, any operation that you perform, there's a place that is being stored. You don't have access to that place. It's called a cache. So that cache is just like a snapshot, a memory, a temporary memory that's holding like some files that are needed to what that are needed to complete the process you want to perform. Then because it doesn't work for only Docker, it works for a lot of tools that need to download a lot of files. So you cannot keep saying that every time you want to download something, let's say you want to spin up a container, there was an error when you were spinning it up. You now want to spin it up again. You need to download the same set of files, at least up to a stage. But because the previous one did not work, then the things you have downloaded in the previous stage as then what they have been discarded, you now have to start downloading again. That will take a lot of time to cause a lot of issue for people. So there's a place that is called the cache. That is in the cache that everything is stored, and then you can use your cache numerous times. So there's a specified time limit for the cache to be stored before it is then deleted. They feel that okay, at least by the time the cache is deleted, they feel you are not using, you don't have any need for this cache again. Like they feel for that time period you should have completed most of your processes successfully. So I'll be the first image I'll be spinning up is the Ubuntu image. So, and I'll go into the details of this Docker file in a minute. So this is the Docker file that I'm using for the Ubuntu image. So I just want to I just want to show you another way that a Docker is. So I've been focusing on one aspect of the use case of Docker. Another use of Docker is a way for you to be able to test. Is a way for you to be able to test your development on other platforms. For example, now I'm using a Windows system, for example. So if I do something like should this work? Change mode. You see, the term change mode is not recognized as CMD led basically. So what this is just trying to tell me is that what you can see is in color red. So this is just saying that it's an error. Why? Because change mode is not identified. Change mode is not identified as a correct command that you can give to a Windows system. Let me see if I try another one. I think CP should also not be okay. CP is identified because it is sorry, Control Z to stop that. Okay. Exactly. So normally CP should not be identified because I think if you go to command prompt, but Windows has tried to synchronize both Linux operating system and Windows operating system in the sense that so PowerShell supports more commands than command line would do. But basically, I'm just trying to show you that when you are trying to, I think something like Echo should not work because Echo is for Linux. Echo is also working. So they have tried to synchronize most of this stuff so that because Linux is basically the go-to operating system for development basically, but is not user-friendly in the sense that most of the stuff there are things that people have to do it for themselves. You have to be able to undo some low-level operations, but Windows have abstracted most of the stuff for us, so it makes life easier using GUI and stuff. So, but over the years, I think Windows have tried to make things very, very easy. cat is also working. So those are the basic okay. But if I use Vim, should Vim work? Okay, exactly. So Vim is not also working. So Vim is a specified editor that comes with every Linux package. As long as it's a Linux distro, a Linux package, Vim is a command that is recognized basically. So these commands that are not recognized is why, because it's on a Windows system. So let's say you are building something that you want to know how it will feel like on a Linux. I'm not saying feel like, but I want to say you want to know how let's say you developed a program now. So you want to know how well that program will perform on a Linux, or you want to be able to test your program on a Linux distro. A container, a Docker container is another very, very easy way for you to do that. There are things called virtual machines also, but if you can use Docker containers, you abstract yourself from a lot of the stress that virtual machines, because virtual machines, like, they need a lot of power to operate and stuff. Virtual machines just like you having a whole new another system on your current system. That's not the subject of today. But with Docker containers, you can easily just like you can just like have a subsystem that is working on a Linux distro, and with that you are good to go. So to just showcase that, now let me come and explain this Docker file here. So this is a Docker file. This is your first. You still see there's still a course in stage B that works on Docker file. One of your example projects that will showcase Docker fully. But basically, there are commands that you can put in a Docker file that will work. It's just like you trying to say English. You cannot use Spanish to create an English word basically. So each language has its own set of syntax and rules that it can use. So basically, it's the same thing for a Docker file. A Docker file has a list of recognized properties that you can use in a Docker file. So if you give it an unrecognized property, you will get an error when trying to spin up an image. So to spin up this image, the first thing we do is to set the base image. I'm also commenting to make it easier to set the base image. So the keyword to set the base image is from. So you're telling that I want you to start this Docker file, because you cannot start saying that you want to start building you cannot start saying that you want to start building an Ubuntu system from the scratch, if you get what I'm trying to say. So using from, you tell it that because for Docker, it has a working hub already, just like the way people use GitHub. Docker has a registry. You get a registry that has a list of what popular images that is being used. A list of images, not popular per se, because you can also put your image or your container to Docker Hub. But you can have a list of, there's an image registry that Docker uses to keep store of images, and from there one can just pull any image that one wants to use for that container or for that image that you want to build again. So you just want to say that you want to pull this image called Ubuntu, you want to pull it from the Docker registry. That is just what this line here is. So from is the keyword we use, and we give it the name of the image and the version. So from Ubuntu, if you don't specify the version, it will pick the latest version for you. But we have specified the version, and I think the latest version is Ubuntu 22, but we're just going to be working with Ubuntu 20. So you say from, and you specify the image that you want to pick, and then you give it the version of the image. And then you need to set the working directory in the container. Of the container. I was typing too fast. Or the container. So the working directory of the container is just like the base directory you will go to. For example, you can see this now. This stuff that I highlighted in my PowerShell. So this is the directory that I am in currently. This directory here, going from C to users to blah 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 blah, work blah blah blah, Ubuntu image. This is the directory I'm in. So what I'm trying to tell this container is that when you start up, the working directory, that means the base directory that you should get me to, is called the app directory. So that is what you're trying to say. This line here is a very important line, but I'm going to comment it out right, because it takes a lot of time and it's like a lot of stuff to download. Because when you want apt get update, so because now you're already on Ubuntu, and we have a directory in the Ubuntu machine already, you can now start to run what Ubuntu lines on it. Let me show you something. If I come here and write apt-get, it should give me an error. It's not confirmed. But if I come here and try to, I have a Ubuntu subsystem here, and if I show you my Ubuntu subsystem, let me just wait for that to come up, and I write apt-get. See, my Ubuntu is also 20.04. Faster. We're still loading up the system. If I come here and write apt-get, it's going to ask me for some things, because you should exactly. It gave me, it's telling me that what these are the commands that I can use with apt-get. So if I just run apt-get updates, then I'm just going to automatically update my Ubuntu system. That is what this does. And you can see it here, updates, retrieve new list of packages. That is what this does. So if you want apt-get updates, you receive a new list of packages, and if you want get apt-get install, you do what? You install the new packages that you just got. So because we have spin up this Ubuntu container, sorry, because in this image that we are working on, we have already pulled from the Ubuntu image, and we already have a directory. We can now do what? We can now run Ubuntu lines on it. So I can say run apt-get, but this will take a lot of time. That is why I've commented it out, because it might take, the last time I did it for my system, it took more than an hour to complete, basically, network and all. So running apt-get will just update and install all of the packages that I need on Ubuntu. And the last thing that I did here is to, let me go back to my PowerShell terminal. And the last thing that I did here is to say that the CMD command. So what the CMD command is just that it runs anything you give it in the next line. It runs it on a terminal in your container. So a CMD command does not work until the image has been built and the container is up, basically. So when you build this, the command is there, but this cannot run until you have a container that is working already. So even though it is in the image, what this does for the image is that it tells any container that is spinned up based on that image, that once this container is spinned up, I want you to do what? Run this on a terminal. The CMD, they call it CMD, but it's actually basically a terminal. CMD is just the keyword that Docker is using. So that's basically how to run a Docker file. Yeah, so this is the very, very key basics of a Docker file. So there are other keywords that you can use based on whatever it is that you want to do. You can copy things, as you see when I'm trying to show you the Python image file and all. But these are just like a basic intro of what a Docker file is. And then to build a Docker file, I deleted the image. So to just do that, you just say Docker. I want you to target Ubuntu image. Okay, and I want you to build it from here. Okay, I have to put the build first. So Docker build build, and then tag Ubuntu image. So this is me doing it from the command line. You get, so there's a way to use the Docker desktop to build images, but I won't be going up into that. There are ways that you just implement, but like I said, the command line version is easier and one of the most supported that you see out there. So Docker build, what T does, T means tag. It's just like you saying that name it Ubuntu image, but they don't use name, they use tag. So Docker build is the keyword. Docker shows you that you want to run a Docker command. That's what it tells like Windows, that I want to run a Docker command, and then build the image from the directory I'll give you. Tag the image Ubuntu image, and you can see there's a full stop there. So what that full stop tells is that I want you to build the image in this directory. Dot is like you saying that this directory. That's an abbreviation for you to start, because if you don't use dot, you have to specify where your Docker file is, and because you are in this directory, you have to start from the beginning. You now start from C to type users blah 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 blah. You get, that is not so. The shortcut for you to build from a current directory that you are, and your directory must have a Docker file. If your Docker file is not in the directory that you are, it will not build anything. It will give you an error that no Docker file found. So once you're in the directory that has the Docker file that you want to build, you just say Docker build. You tag, you give it the flag /t. /t is the flag that you want to target this name, and then you specify dots that this is where. Let's say, for example, now your Docker file is not, you're in a folder that does not contain your Docker file. You say dots, then slash. You get, then you write the name of the folder that contains the Docker file. But since I'm in the Docker file that contains the Ubuntu image Docker file already, I'll just say dots, and then I'll run this, and it will show us the output of trying to run it. So you can see, I will show you where it is using the cache instead of downloading. The first time I did it, it downloaded, but in this step, it will use the cache. It will show you that it should write something about cache. It will be very, very fast actually, but Ubuntu is not building any Docker image is not that fast. You see exporting, you see cached, because it was what cached before. That is why. If it wasn't cached, it will have to start this whole process from the beginning and then start downloading stuff and doing this library Ubuntu. It will download all of this. But because I have done that before, it is just like from the cache, just working this. So I have a Ubuntu image that is done already. So if I come here and let me change my screen to the Docker desktop again, exactly, containers this, and share. If I come to my images in Docker desktop, you can see that the Ubuntu image that I deleted before is now here. It has been viewed, but you can see that it was created about 3 hours ago. So it's the time it was created is just the time it was created is always the same. So no matter what, as long as it has been created, it still gives you the same name, unless it's a new Docker file that creates it, or there are new things in the Docker file. But if the Docker file is the same, it will still give you the name. But you can see that I deleted it before, and now it is what it is here. So it was created 3 hours ago, yes, but we just spin it up again. If I do something to the Docker file to change it, the new image will contain new things, and then it will now change this, but it will still have the same name as long as I target that name, Ubuntu image. So that's the first, but there's still no container running on it. So one, okay, I have to change my screen. Let me change that to my VS Code back. Okay, so now that I have finished with the building of the image, I need to now run the image, and the Docker code to run that is to say Docker run it. So that's just the keyword, the flag. So Docker run means that you want to run a container. So you want to run a container based on an image. So you give it the flag it to specify what the image that you should run with. And we named our image, we named it what? Ubuntu image. We named our image Ubuntu image. And then when we do this, the next thing to give us, it will not write out something like PS. PS means PowerShell, and then this. It won't write this out. The next output we should have is an output that shows the name of the Docker container /app, because we specified the working directory to be app. So the root of the Docker container. So this is the way Ubuntu system works. If you come here, you can see that my Ubuntu system here is also showing blah 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 MSC and stuff. But the way Ubuntu system works is that this is how it shows in the bash. So with this now, I have a Ubuntu system. So now if I run apps gets, I should have the same. You see, now I'm having the same result as I had in this my Ubuntu terminal as usual. But you see, I have this another one. Which one did I try to run then that did not run on Windows? Let me just try to check that. Sorry. Okay. Vim. Will Vim work? Because I did not finish add-get, I'm not sure Vim will work. But what was the first one? The first one is change mode. So now change mode should not give me an error. Change mode should just ask me the name of the file or something that I want to change mode. is missing an operand. So if I do change mod help, you see now it's telling me that, you see, change mode is actually something that I can use. So that's basically one of the things that I can use with Docker. So let's say there are things you want to test out in your system that is only compatible for Linux system. With this now, you can test them on this system, and you're what, you are good to go. You'll be able to have a first-hand info of the behavior of your development or the behavior of your app on an Ubuntu system, and that is very easy. So there are many more ways to extend this. You can then give it a volume, because anything we do now, once we destroy this container, all of our files are destroyed. So there are ways to persist files. So I can just create a file now. If I create a file, touch r.txt or something, and press enter, I have a file. If I list my files here, r.txt, I can do, you get, these are just, if I do touch on a normal PowerShell, it shouldn't work also. So these are just ways that you can just what, it's like you having, is very powerful. You have like another system on your system, and you can basically perform everything that you want, that you would have performed in a normal Linux system on your system, and free of charge, and there's nothing that you have to pay for anything, just your data. So you can extend this and make it more powerful, but that's basically one of the very functional uses of Docker. So the other one I'll show you, the other container. Okay, let me just show you my, my Docker desktop also, for you to see that I now have a container that is running. You can see now I have a container that is running, but it's very strange. It's called strange during the, that is why, that is because I did not name the container when I was starting it. If I had wanted to name the container, I would have provided a tag called name. So if you don't provide a name, Docker will just use any random name to stand up the container, but you can see that it's using what, the Ubuntu image. So I will do that. Let me just come back here and then show you guys the Python, let me show you the Python container and the Python image, and with that we are done for today's live session. So I'll just leave this here because it's still on. I'll just go to another terminal. This is another another PowerShell terminal basically. And you can see that now I'm in the Python 36 image. In the previous terminal, I was in this folder, but now I'm in this folder. So if I list in this place, I also see that there's a Docker file here, a Docker file. So I will go to the Docker file for this one. Okay, where is that? Docker file for this image, and let's just go through the syntax of the Docker file. So it's basically the same thing. For me, I'm just pulling Python 3.6, and that is another use of Docker. So with Docker, when you are working with a programming language, for example, let's say you are working with Python, but you want to you want to use a Python image that we don't want it to conflict your own system. There are two ways to do that in Python, but the Python accepted method, which is the using of virtual environment. Sorry, the using of virtual environment. Virtual environment is basically good when you want to use packages, but virtual environment still uses your same Python engine. But with Docker now, there's a way that you can get another Python engine still on your system and test it. So let's say, for example, I wrote my code firstly in Python 3.6. So when I'm not trying to port it to Python 3.10 or something, I'm having an error. One of the best way to make debugging easy is for me to first work on it on 3.6. And the only way you can, it's not easy to have two Python systems on your laptop. It can cause some namespace issue. So Docker is another easy way for you to have that functionality of having two different things on the system that will not clash with each other. That both of them wouldn't clash with each other. For example, now if I come here and try to show my Python image, okay. Sorry, just stop now. Okay, by Python, no, what's wrong. Let me just reduce my exactly. That's giving me an issue. Okay. Sorry for that. So if I come here and type in Python Python, don't know what's wrong with this stuff for me. Let me just try to switch back to this one. Just reduce my screen because I don't know why this issue is occurring now. Sorry for the delay in transmission. Okay. Sorry for that. I didn't even know that the connection, but that was from my browser. Let me just share my screen and continue with this. So if I come here and just type in Python, and enter this, you see that my Python version that I have on my system is Python 3.10, 3.10. But with Docker, I can have a Python image of Python 3.6 or even Python 2 or any Python that, as long as it has been specified on the Docker image registry, I can get a Python image of any version and then work with it to be able to like get what it is I want to work with. And it is also the same thing. Let's say, for example, you are developing on your system with Python 3.6, for example, and someone that is using Python 3.10, you want to share your code with the person. If you just share your code files and all and share it to the person might run into issue of trying to, the person might run into an issue when trying to run your code. Why? Because the person might not have the same modules that you have installed, for example, or the person, because of you coded in Python 3.6, when Python was updating to 3.10, they might have deprecated some methods or stuffs. But when the person is just running your code just with your files, easy way to ensure that you are putting the same thing with the person is just to use containers and dockers. So you can see now that I have what Python 3.10, sorry, 3.10 on my system as it is shown here. So I will come here and exit my Python. So I'll exit this here, Control C. Okay, I'm very sorry for the break in transmission. I'm really sorry, but I think I'll have to end this session at this stage. I hope I was able to communicate a little because I don't know why the network is freezing up anytime I'm trying to share my screen again. I'm being disconnected automatically. So I have to use my phone now to connect to the meeting so I can be able to just round up. So that will be the end of today's live coding session. I will work on this, and I tested extensively yesterday. I'm shocked this is happening today, but I hope I was able to just build on the foundation of Dockers. I will also like touch up a bit on this in the next live coding session before I commence the next live coding session. And as I've said earlier, there will also be a stage in the course that works extensively on this. I just wanted to introduce us to what Docker is and what we can do with it. So thank you for today's coding session and have a wonderful